Good morning, everyone. My name is Anurag. We are going to start this session in next 5 minutes.
Careful with the glasses. If you don't want the glass, I can remove them. Yeah, that's probably better. Yeah. Because your microphone and
All right, I think we are going to start now. Good morning, everyone. Welcome to the session. My name is Anurag Bhatia. I work at Hurricane Electric, and I'm part of Epinic 46 PC. I'd be moderating this session on CDN and Cache. So essentially, we'll be starting with a presentation from Krishna Pokhrel, who works at NetSurfer in Nepal. They operate a network in Nepal, and he's going to present about community-based CDN node and caching. And after his presentation, we'll proceed with the excellent panel we have with multiple CDN players as well as internet exchange, and with a panel discussion and Q&A. So I'll welcome Krishna for his slides.
Yeah, this one and this one, right? Yeah, okay. Yeah, thanks. Thank you, Anurag. Good morning, everyone. I'm Krishna Pokhrel from Nepal. I'm going to present on community-based CDN node and caching hosting. As we know that internet traffic, everyone is using Facebook, YouTube, and those most of the contents are coming from CDN providers. There are so many CDN providers. So whether ISP are giving committed bandwidth or not, users are measuring internet based on suffering and watching internet content these days. Whereas most of those contents are coming from CDN providers. So one of the major factor for the internet these days is like, CDN cache node, whether ISP has CDN cache node or not. And CDN providers, either they are just setting up their data center within, the economy, and they are providing connectivity to ISPs, or they are just hosting cache node inside the ISP. In both scenario, the factor they are just giving those nodes or hosting those nodes are like, the volume of bandwidth, volume of user from those area. If the bandwidth is higher from that area, or the volume of user is higher for their content, then they are just hosting their nodes. So from the ISP or user prospect, whether user is in less bandwidth consuming area or service taking from small ISP, for them internet should be same. And yeah, there's an option. IX are there, so IX can host cache node or nodes so that every ISP could connect and get the content locally from there. But IX might have their own interest or their own business or their own policy, like just to exchange data, not to, host cache node or kind of thing. Transparent caching, we were using transparent caching like in ISP that were helping to somehow to get good experience to the user. But due to SSL, the transparent caching are, the uses of, the output of transparent caching are just decreasing day by day. So we have to go with the, CDN cache because the contents are, more contents are in CDNs. So for the small ISP or for the some particular area, the location or for a small city, we can form a community or consortium to host cache node. Why? Because CDN providers are qualifying, based on bandwidth uses, bandwidth or users. So even a small ISP can qualify or can meet the criteria of CDN providers. And the other benefits are like, can share that CDN nodes, and less internet feed is required than the individual node hosting. And user can get better experience because more content, will be cached because of high number of, uses. And definitely it will minimize the cost, operation cost. And just how it's minimized, because we can share those operational costs within the member of consortium. So how we can just make it happen, like, in a community, more expenses can be reduced voluntarily sharing technical and operational job. We can make transparent and open calculation mechanism and can use some formula for higher consumption, low rate. Polling fund for further expansion and upgradation. Internet and other auxiliary service provider for CDN should be selected through the community-based competition bidding, because we need to feed the internet to those nodes. Some company will be liable for billing, because in a community, there could be like, who is going to bill or who is going to calculate the finance kind of thing. And same company will be liable for the billing and other administrative work related therefore of. The IP can be leased, or any community member can contribute voluntarily like free of cost for that data center or hosting node. As we all know that, okay, just, and even from that consortium, we can host transparent cache. I mean, in shared basis. This just it's a proposal. I mean, we are just having discussion, though there is a technical complexities there. As we all, I mean, know that transparent caching is not serving as we are expecting because of more SSL content. Investing more on it is not future-proof. So we can invest jointly and can share until it will be usable. Still, we can get effective result sharing because sharing within, I mean, the members. Because more content can build if we have more user or more bandwidth consumed from there. SLA won't be affected because PVR caching can be used, so every ISP or member can control their traffic, whether they want to send towards that transparent caching or not. Still, it's in discussion. Definitely one-time complexity, setup complexity is there, but we can buy good caching software or hardware with a shared investment. And IPSLA can be used, I mean, for the reachability and availability check. So this is the diagram just I proposed. Definitely there are some technical concerns, so we are just having discussion with the technical, I mean the vendors, whether when we go with the high bandwidth, then what kind of problem could occur. But the transparent caching vendors are just confirmed that it's work. Still, I mean, the router providers, they are just not confirmed yet. But definitely we are going to host in our community. We have a consortium, I mean, the community-based hosting in Nepal. We have we are hosting since 2017, participating of 6 ISPs. The community is currently hosting FNA. Thanks, Matt. He provided us a node. And still we are approaching with other CDN providers to provide their cache node or nodes for that community. We are leasing a rack from third-party data centers, so I mean, everyone can easily connect there. One of the members is providing IP for free of cost so far. And one of member from the community has been handling billing and other administrative work. After winning a competitive bid, every year the bidding is, open bidding is happening there. And we are using some exponential ratio to share expenses based on bandwidth consumption, that's 95 percentile. So far the community is working seamlessly. Other ISP are also interested so far in our mission, and discussions are going on. Hosting transparent caching is in discussion. As I said, some technical concerns are there, which we are having discussion with the vendors. Yeah, that's my presentation. Thank you.
Thanks, Krishna. Before I proceed further, I'd introduce our panel members, and we plan to have an interactive discussion, so we would not have any Q&A in the end. We would have Q&A during the panel discussion. So if you have any questions, feel free to ask during the discussion. I'll start with Jethro. And introduction, please.
Morning, everyone. My name is Jethro, and I'm from the Vanuatu Internet Exchange. That is the exchange that belongs to Vanuatu, which is located in Port Vila. Thank you.
Hey, I'm Matt Jansen. I'm the Edge Strategy Manager for Facebook in Asia Pacific. So handling all our outward-facing connectivity, caches, peering, and so on.
Good morning, all. My name is Martin Levy, Network Strategy over at CloudFlare. So content delivery and cache fill will be my topic of conversation this morning.
Hello, my name is Cam Young. I'm a network architect of Akamai. So I'm doing the capacity planning, infrastructure build out, the peering IX, as well as the major eyeballs cache server for Akamai in Asia.
So we have three members from CDN and content community, and we got two members, one from an IX, another one proposing a solution which works close to an IX. So we'll try to keep it as interactive as possible. Let me start with Cams about how Akamai works. This is a question I personally keep on hearing from a lot of my friends who are running ISPs around. How does Akamai maps the domain names or the customers which they host to the nearest node? Cams, can you explain us?
Sure. So the basic idea I think Anurag mentioned is we're trying to map our customer host name to the nearest, although it's not called nearest, I would say the optimal Akamai nodes to serve the end user. So what we do is we basically work with a lot of ISPs to install cache server from them, and then from there we work with them about what traffic that we can serve from that node. And then we also have our infrastructure node that we can serve it to everywhere or connect to IX. So that's basically from the Akamai CDN system point of view, we do have many paths to serve to end users. But then in reality, what we do is we do a lot of active measurement about which node is closer to the end user. So we measure the latency, the packet loss, to, let's say, from this node to the end user here, and then to see where which nodes are the closest to the end user. Of course, we also factor in, like, for example, like the bandwidth, the server healthiness, of course, also the cost, etc. So this we factor in all these parameters, and then we figure out what would be the most optimal Akamai nodes to serve the end user. And then we do the DNS mapping. So the end user, when they queue it, they use a DNS IP. Usually, most of the cases, they use the ISP DNS. And then if you have a cache server with the ISP, then we map the traffic to that Akamai node in the ISP. If not, then we will fail over to the next optimal nodes where we can get the prefixes and also with the optimal latency. And we do map also based on different content types. So different content would have kind of different priority. So let's say a download traffic, maybe we could afford them to serve it further away if cost is prohibitive. Or we could, say, let's say, e-commerce content, we will try to serve it as close to the end user as possible because we know that the performance, the latency matters in terms of the e-commerce transaction. So basically, we are a DNS-based mapping. We do have also consider a lot of different metrics. But if you have any details or questions, just feel free to contact me later.
Thanks, Cams. I'm going to keep the same questions for other CDN players as well. Martin, can you explain how do you map your users to the nearest node? How exactly CloudFlare works?
Yes, radically different, and by design. So it's very valid to map the internet and to use your DNS environment to decide where to go. But CloudFlare does things very differently, and we're a very heavy user of Anycast. And Anycast is, on the surface, a very simple technique, but it actually takes a lot of management. So let's talk about just what the end user sees and then work back to how this operates. The end user always gets given the same IP address, independent of whether they're sitting in New York City or right here in this room or anywhere. But then we rely on the fact that with a very large number of nodes around the world, that although we announce the same IP address in every location, that's the Anycast methodology, that people's networks are correctly tuned such that from here, the nearest node is whatever the internet connection from this island out to the rest of the world is, if there is no node here. So we end up delivering from Sydney, Australia into somewhere like here. But if we were a home user in Hong Kong or Singapore or London, then you would end up with a node that's local to that. Now, Anycast is, as I said, a very simple technique, but actually takes quite a lot of debugging and takes quite a lot of support on the back end. And I could say life is easy and just do it, but we're here to educate and learn, so let's explain the hard part. The hard part is when people configure their networks incorrectly or questionably or without thinking this through 100%. Because if you are, and I take the simplest example, if you could imagine with me, you're sitting at a point on the globe and you have two diverse locations. One goes to your next door country, and one goes, well, quite a ways away in the other direction, but it is your redundant path and it goes off to some major city somewhere halfway around the world. Well, Anycast wants to make sure that you are delivering bits from that close point, the one with the shortest path, the lowest latency, therefore, in theory, the most efficient. But if the internal metrics of how that network operates says that it's the same metric, the same network distance to go east or go west, where one goes a third of the way around the globe and the other one just goes to the next door neighbor country, well, then bad things happen. You start delivering bits from far, far away. So we do a lot of monitoring. And we do a lot of monitoring to the point that we turn around and say, well, is this AS number or this country or this particular network delivered from here or there? Is it efficient? And if it isn't, well, pick up the phone or the equivalent thereof and tune appropriately. Now, this works. If it didn't work, we wouldn't be doing what we're doing. But it also has a secondary effect. Just about every time we phone a network and say, hey, you know, this doesn't quite look right, and you're delivering stuff from halfway around the world when you really could be local, they sort of go, oh, yeah, our network does need a little bit of tuning. With slight exceptions, there are economic issues involved. Sometimes a link may be very close, oh, but expensive. And sometimes it may be very cheap to go further. The economics of the internet are not linear, let's say. But internet peering points, large amounts of connectivity, that's what makes Anycast work. So that's our predominant method. We put everything everywhere. We DNS answer the same everywhere. And that has some interesting, nice side effects. In other words, DNSSEC is very easy, so we can enable security on DNS, et cetera, et cetera. But that's the A-B comparison.
Sure. I think I have a follow-up.
The AC comparison.
I think I have a follow-up question right here. Don't you think Anycast just takes you to the shortest AS path instead of the geographically shortest path, and that can always be a problem?
Yes, yes. So you're highly dependent on the network. So short AS path, and if it's equal, then you look at the IGP, the internal metrics, which you don't have visibility because they are internal to somebody else's network. Absolutely. So if you do Anycast and you turn up 2 or 3 or 4 locations around the globe, you're just not going to work very well. You turn up 10 or 15 locations, now you see light at the end of the tunnel, but you can see tons of situations where this doesn't work. You get to, 100, and then things start getting to work a lot better. As I said yesterday when I spoke about 1111, we're about 170 locations around the globe and growing. And every time you put a location in knowing now with a lot more metrics, oh, that will break the traffic left or right, that will improve the connectivity, obviously, if you deploy in-country for a particular country. You still get some wonderful edge cases. But the bottom line is you can't do Anycast with 2 or 3 locations. You really can't do it these days with 10 locations if you're trying to do a significant deployment. And the large numbers work.
Matt, same question for you. Can you explain how Facebook does the caching?
Sure. So, I mean, it's an interesting selection of panelists because we all use more or less different methods to achieve the same thing. So Facebook's traffic is really 2 different classes of traffic you have to consider there. We have dynamic traffic, that's everything that's real time. That's like messaging, that's like your actual news feed, all that kind of stuff. That will always connect to a POP of ours. And the mapping for that is very similar to what Akamai does, directing you to the nearest pub. So from where you are here, you would go to Sydney for that in the vast majority of cases. And then we have static traffic. Static traffic is basically all your images, all your videos, elements of the site, like JavaScript elements or whatever, CSS. That stuff is cacheable, and that stuff is actually targeted based on your end user IP. So that's yet a third method of doing that. In most cases, probably the most precise one, because we actually know the end user IP, and therefore can actually map it based on that. So you avoid issues where somebody configures a stupid DNS server somewhere halfway around the world and stuff like that. We can do that because it is our own content and we have the end user IP. That's very difficult for a third-party CDN like Akamai to do. So that enables us to map most of that traffic a lot more precisely. So in the case of New Caledonia here, we have a cache on the island. Your static traffic, your videos, your pictures will go to that cache right here. So you should get a pretty good performance.
Interesting. You brought a comparison of the nodes with CDNs like Akamai. It would be good to share that that was your last employer, isn't it?
That is true. I used to work for Akamai, so I think I have a fair understanding. I think when you see Akamai presenting how their mapping works, that's still a presentation I wrote.
All right, fair enough. I'll proceed with Jethro. Jethro, can you tell us more about Vanuatu IX? Where that is and how many members you have got, some introduction for the members who are not aware with the place.
Thank you. So Vanuatu IXP started around the end of 2012. And initial pairing happened about February of 2013. At the moment, we have about 6 members, all our network operators, 2 large ISPs, while the others are smaller ISPs, including also the Vanuatu government eGov infrastructure. So we have 6 members altogether. And at the moment, the CDNs that we have a Google Cache, Akamai, and a couple of root servers. Traffic that we're seeing hitting our IX is about currently 400 plus megs of traffic. However, that doesn't come from all the prefixes for Vanuatu. There are some prefixes that we haven't yet advertised to the caches. So it's something that we're working on. Expecting that once we have all the prefixes advertised, we would see an increase in our traffic as we advertise the remaining prefixes to the cache. Thank you.
Thank you. Krishna, can you tell us more about your effort? Of course, we saw the presentation. Can you share which of the caching servers you have got and how hard it has been to convince the content players to put caches?
Thanks, Anurag. Actually, CDN providers, they look bandwidth. I mean, how much bandwidth coming from that AS or whoever is requesting, how much bandwidth is coming from downstream AS from that provider. But as a ISP customer, whether that connected to a big or small, they always trying to, compare with the other ISP. So if one ISP who has good, bandwidth with some particular CDN provider, and they provide a node to that ISP, and another ISP who doesn't have that node, definitely they are suffering. So we almost 4-5 ISP, we were just trying to get cache node, and we requested to the CDN providers to provide, but we are always getting like, your bandwidth is still not reached to qualify, so we will just try after 1 quarter and again review your application kind of thing. Then we just thought that, okay, why we should suffer, why our customers should suffer just because of caching. Definitely, I mean, if the cache is nearest, then the performance is good. So customers start moving to another ISP because of that thing. Though we have a good, I mean, the transit, we are just maintaining all the QoS and all the thing. And we made one consortium who was suffering with those problems. And we started, I mean, this thing, and at least we could meet the requirement of Facebook. So we got FNA from, and I requested Matt, and they provided FNA. And we are struggling to get Akamai or Netflix, CloudFlare, just because of the volume of traffic. So still, I mean, requesting to get, I mean, those things. Hope we'll see. We'll get soon.
Sure.
This is really a great introduction to one of the interesting problems with deploying a CDN node. Split the problem into two halves. One, getting enough bandwidth into the content delivery network node to fill the cache, which as a consortium you propose a solution, which does work. That has worked in various places around the world. It normally involves a fair amount of math in calculating who pays what, but once that's agreed upon, should work fairly smoothly. But the second issue is the issue of size. And this is something that the different CDN technologies and methodologies actually end up with different responses. The way we work at CloudFlare, we can't build small nodes into the model that you propose. We can build big nodes because every node does everything. And so we're quite aware of where it makes sense bandwidth-wise to put a node, and to be honest, where it doesn't make sense. But that isn't said from a capital expense point of view. A rack of equipment, you can sort of look at a rack of equipment, and any good network engineer, server engineer, $50,000 or whatever the number is. That's not a hard thing to do. But what's more interesting is to understand how much bandwidth that serves, and then to look at the cache efficiency. And this is, again, where the model is radically different amongst us. And if we had somebody from a famous video streaming with a red envelope company, or a very big search engine here, each one of them would actually have a very radically different mathematical model for how their cache works. We all strive for one in, many out. That's the efficiency. That means going into anywhere, and going to an IX or going into a consortium means that your consortium members would pay 1 unit of currency, but actually would get many, many units of currency back in savings, and therefore it's an instant win. But cache efficiency has a lot to do with how big the cache is and how much it's used. And as you look at caching, it's radically different when you look at, if I may say, a Facebook homepage with a set of very known assets, and then it changes dramatically, to CloudFlare, where we're sitting on 10 million different zones, where, quite frankly, it can be very different usage. Taylor Swift may be big in this country, but maybe not be big somewhere else. A good cricket match comes on, and wow, the whole Indian subcontinent is, well, all cricket all the time. So and rugby for the appropriate people in the audience. And I only use these as simple examples to be obvious. But it actually radically changes the deployment model for content delivery networks. So I commend you, because we've used this model to solve the content fill aspect. Now the next issue is to fix the size issue, because for a lot of deployments, it really boils around solving the big places first. You mentioned that you have 2 root servers. Now, they're not content delivery networks, but they are caches of a highly, highly engineered type. But they're so much easier to deploy because they're this big-ish, that big-ish, and yet they're very valuable. They provide a great response. If content was that easy, you'd see even more nodes out there, that's for sure. Anyway, so that was my response.
Sure. And I think this is something I hear a lot about root servers, since you mentioned. Even though they may have very low traffic, they are extremely important to have for a number of reasons, for resiliency as well as for reasons like a local root instance is good for bearing a DDoS towards a root zone server instead of having it far away and choking your network bandwidth.
Mm-hmm. Yes.
I'd proceed with CAMs. CAMs, I think Akamai is huge by the numbers we always see with the cricket matches. Always have friends sharing graphs with me during the cricket match in my home country, India, where there are popular events like IPL, and the traffic shoots up like this and stays like this, and you can even figure out when a break is just based on the graphs. So for those kind of surges, I think network-wise it does make sense to have caches as close to the end user as you can by putting them in the POP. But I was wondering, do you support CDN connectivity to an IX, which is not connected to your backbone?
So yeah, what you said in India, I mean, just a particular since Martin and you mentioned about cricket. So so the cricket is really a huge traffic. We actually published the report online on our website if you want to see some data. But then we've come to the challenge is actually the cricket is like an event based, which maybe only like several weeks in a year. So when we have to discuss with ISP or IX or whoever, there's always a challenging way to discuss. One is actually whether the network partner would willing to give us a huge port and huge workspace to install the servers, because most of the time when they are not event, these are actually pretty much idle. The other way is whether we also, from a economics point of view, whether do we, as an Akamai, does it make sense for our business to, let's say, invest in CapEx to deliver this kind of event? But then this is more on the our internal commercial discussion. But back to your point, we do connect to an IX. There are multiple reasons, of course. One way is because they are small ISP that not justified for a Akamai cache node, sorry to say, but it's tied to the cache efficiency. But we do connect to a lot of IX because IX is basically a point that we can aggregate a lot of small ISP. So we do work with a lot of IX that we have a program called AAMP-IX that we deploy cache server with an AAMP-IX, I think Jeff will get one. And then that we also looking for any IX that trying to help into the community that, let's say, they are in a rural city, but they could aggregate some small members. So that could be one way that we look into IX. Of course, there's a commercial IX that we also connect to, because we could be, the commercial IX from our point of view will be like a failover or an overflow scenario when the on-net cache node inside the ISP fail. Then it's always go to the next point when we don't want to send food from transit, because transit one is expensive, the other way is transit bandwidth may not be enough to serve the overflow traffic to the ISP, but an ISP usually have a larger bandwidth with IX. So we connect to IX in, one is aggregate with the small members, one is as an overflow or redundancy point of view. And we also, there's some specific content that we have to serve. We cannot serve it from an ISP. Even you have a cache node with an Akamai cache node, you may not have all the content. For example, you may only have HTTP, but you don't have HTTPS. So in this case, then we'll be maybe serving HTTPS content through the IX to a ISP, for example. So these are some use case on how do we connect to an IX. Of course, it's still tied to like the economics and also the size of the IX, whether it's worth to, I mean, the aggregated size of the IX, is it worth to connect to there?
Sure. Thanks, Cam. if someone from our audience is running an IX in Pacific, what would be the need in order to have Akamai host a node and offer it to their members?
Yeah, so we will have to, like, number one is discuss on the traffic volume, the projected traffic volume. So we do have data that we can tell how much traffic to a specific network to AS. So if I know the IX member, then we could calculate the projected traffic would be. And then we will see whether it justifies for the size. Because a small size cache server, let's say only 500 meg or so, it will not be a lot of cache efficiency, because that means there will not be a lot of end user. And that means a lot of end user may be browsing different Akamai content. So that means it's actually also don't have the cache efficiency. And the end of that, you may have a lot of cache field traffic. Let's say you may only have 1 to 2, but ideally we want to go it up to like 1.5 or even 1.8. So that means 1 meg in, we can send 8 meg out. So depend on the size. One is the other thing is that we also depends on the performance. So we do deploy in a lot of Pacific Islands, not all of them, but because if we know that if you don't have a cache server, the next hop is probably for a satellite link somewhere in Sydney or etc. So that impact the performance also, because ultimately we are a commercial CDN, so we have to bear the performance for our customer. That so this is also the size and the performance both matters when we deploy in Pacific Island. So we do build in mics like PNGX that we co-work with Epinic, and we deploy one in Vanuatu, etc.
Cool. One point I want to add here is that in order to have a content player at your IX or even in your network, one starting point is, of course, contacting them. And for contacting, you can always use peering DB. One of the challenges which many of the content players face with peering DB is that the party who is contacting them, that is the networks who are running, the folks who are running networks in those areas, they do not have a peering DB entry. It's very hard to know who to speak to. So if you're running a network, please go and if you have an ASN, please do have a peering DB entry for that. It would make life a lot easier for everyone to communicate. Martin, I'm going to skip you this time. You already stole a slot. Maz, sorry. Slip of tongue.
Close enough.
Oh, well, we are missing Maz, of course. So, Matt, Krishna mentioned that you are present with FNA Node in their consortium. Can you help us understand what kind of technical and commercial requirements you would have if, in order you want to deploy a Facebook FNA node in such consortium, or maybe in a small internet exchange?
Yeah, probably should split the two cases, right? I mean, this consortium is one of the very few examples in the world where this works well. Quite frankly, our experience with that kind of consortium is really bad. Because there tend to be disagreements between the consortium members very quickly after you deployed it, and they go on about like who pays what and whatever, and it dissolves. So we really have, in most cases, stopped doing that because we had very bad experiences, mainly in other parts of the world, not as much in APAC, but we don't have a lot of those kind of deployments because in many cases, they just didn't work well. We have one example of that in the Pacific, which works, again, but like this is a very case-by-case thing. This is not something we would do in most cases. An IX is definitely something we would prefer to support instead of a consortium, because that's a much more established structure where you have much clearer responsibilities and so on. So we have deployed with a couple of IXs. We're very happy to do so more. I mean, right now in the Pacific, great example is PNG. So we have just deployed a cache on the IX in PNG. It's not operational yet. We're still waiting for the local folks to fix a couple of things, but it's going to be live pretty soon. And we're happy to support that in other cases. I think the main challenge there is what Martin was talking about earlier is scaling. Sadly, the vast majority of the Pacific Islands don't have enough traffic for a cache, our kind of cache, to work. That's really our biggest challenge there. Our traffic is user-generated traffic, it changes very, very quickly, and it has a fairly low cache hit ratio compared. I mean, you have essentially a spectrum. Like if you have, like Netflix is a prime example of the best possible use case for caching. It's a fixed library of movies. They know which movies people are gonna watch. They can cache fill that off peak and so on ahead of time. Our use case is probably close to the other end of the spectrum, where we have a lot of very short-lived, popular user-generated content that 6 hours later might not even be relevant anymore. So that decreases the cache efficiency, the hit rate, and therefore means it just won't scale too low. And that's really like, if we're looking at your example, I'd love to deploy a cache on your IX. We talked about it before, but right now there's nowhere near enough traffic for that cache to work. It would simply heat the room. It wouldn't do anything. And that's our biggest challenge in the Pacific. I mean, where we can make the scale work, and then IX is the prime example of where you can like get the whole island, the whole country connected to one point. We love to do that, and please speak to me. I'm very happy to evaluate that. But the sad reality is that in many places in the Pacific, we just, even if we have every single IP in the country connected, we don't reach a scale for the cache to actually work.
Sure. Apart from the concerns on traffic, which I'm sure you and Martin stressed on, what is the other technical requirement you would have for connecting to an IX?
Well, I mean, you mentioned peering DB. That's actually a good point. This is mandatory. We will not be able to actually set up on an IX if it doesn't have a peering DB entry and the members aren't on peering DB, because all our automation actually works based on that. So that's a good starting point. Technically, otherwise, I mean, essentially, we would need the space and power for the cache. We would need the port on the IX, and we would need a port for the cache fill. The sizing of the cache fill very much depends on the traffic, right? This is essentially just a ratio, and the bigger the cache, the more efficient it gets. But like as I said, in the Pacific, we tend to be at the very low end of that spectrum.
Sure. Jethro, I have a question for you about how would you do cache fill when you're hosting CDNs at IX. The question remains mostly on the commercial part about who pays. Let's say you have 10 members, out of which 2 have CDNs, let's say 2 have Facebook node, while others do not. How would you split the cost of the cache fill bandwidth in such scenario?
Thank you, that's a good question. Since the beginning of the launch of our IX, we had everyone pairing with each other. Now the next step is getting the IP transit. When we were talking to guys like Google and the others to bring the caches in, we had to prepare the IP transit. And that's the real tricky part for us. How do we get the IP transit? Who pays for it? And initially we come up with a temporary arrangement where one of the members provided IP transit bandwidth to be used for cache fill. And so we used that temporary arrangement for up to, I think, 2015. Whereby due to some legal issues, we had to stop that arrangement. And that affected our CDNs, which were in our cache. And so we were working on another solution. And fortunately, we came up with another solution last year, towards the end of last year and beginning of this year. We started using that. We started serving the caches again with IP transit. And so that is the arrangement that we have at the moment, where we managed to secure bandwidth from the cable provider. Now, in terms of cost, the arrangement that we do is that we calculate the payment of, well, the idea was that everyone will contribute in the cost for the IP transit. And so the way we calculate the cost that everyone has to pay is dependent on how much traffic that they're generating to the cache. So we work out the percentage of traffic that exits from the IX to the ISPs, and then we get the percentage and apply it to the cost of the IP transit. And that's how we used to distribute the cost of the IP transit to each member. Thank you.
Sure, thanks. At this point of time, we can have some questions from the floor, or if we have from any remote participants, feel free to get onto the mic. Please do state your name and affiliation before the question.
Okay, Jeffrey Zhang from Juniper Networks. A question about the filling of the cache part. Let's say you have decided that you have some content, high volume traffic need to go to a large number of cache nodes. What's your best way to actually push the content over there? Do you just unicast, or do you consider multicast and decide, and that's not worth it?
I'm going to map this question to the CDN players. So, Matt, maybe you can start.
Yeah, I mean, I think the premise there is probably wrong for most of us, because most of us don't push content to cache nodes, right? This is on demand. There is some scenarios, Netflix again being an example, that actually do distribute content like off-peak, push. The vast majority of CDNs are pull, so it's on demand. If somebody requests that object, the cache doesn't have it in the cache, it is a cache miss, and it will then pull it. So this is actually, for I think all of us here, not applicable.
I see. But I do have a follow-up question on that. So in Facebook case, when you do Facebook Live, how does that work to the large scale? I'm just curious.
So the live stream is essentially treated as a video. It's essentially, it pulls one copy of that. If there is a single request, it pulls a copy of that from our nearest POP and then distributes it. If there's more than one request from that cache, awesome, then it just distributes it. So the cache essentially acts as a multiplier, but it is unicast traffic.
Okay. All right, thank you.
Hi, this is Chihu from APNIC. This question is probably more for CDN. I understand, actually you may have different arrangement for the normal HTTP requests and the encrypted HTTPS requests. Can you share with us more? Do you have two sets of servers? And for the certificates, how do you handle them?
I guess that's a CAMS question.
Yeah, so yes, we do have different type of content. So majority of them, I would just distinguish them as like HTTP and HTTPS. HTTP is more easier because they are public websites, so everyone can access anyway. So it's not like a major issue. But in terms of HTTPS, then there come to be a few of criteria. So one is that because the HTTPS, then we actually having the customer certificate on our server. So that's why the security is a very important thing, because we have to make sure that we have PCI compliance, because the customer that who use our HTTPS service is more like the bank, or they do e-commerce transactions. So in terms of the physical security, we need to have a dedicated Akamai web with camera, security log, etc. So this is one way that is different than the HTTP. The other thing is also come to the volume, because HTTPS is not, I mean, it's growing fast, but it's still not the majority of the content that we have. So in a typical case that for an eyeball network, we usually see like 10 to 15% of the Akamai traffic is HTTPS. So that would even make the threshold to put an HTTPS lower. For example, like a community IX, then we have to get enough traffic to justify the HTTPS first, and then they have to be even larger to us to justify the HTTPS. So it's also it's become a issue of the a scaling issue. The third point is for HTTPS now that nowadays we still have using the traditional HTTPS. What I mean is a unique for each FE of our customer hostname, we still need a unique IP address. So when we deploy HTTPS, that means we have to use a lot of IP address, essentially like thousands of IP address to deploy HTTPS node. Of course, we do have some on the inventory ourselves, but most of the case that when we talk to the ISP, we hope that they could provide that IP address, and the scale IP address is running short. So a lot of ISP come to us that they don't have enough IPv4 address. Of course, we do push IPv6, but a lot of customers, they are dual stack, so we cannot just deliver on v6 only. And of course, we are also promoting the solution that push towards like SNI, that we don't require a unique IP address for each host name. But this is still something that in a early adoption way, so that we hopefully that we could still we could support the HTTPS traffic through SNI. Then at that time we don't need a unique host name per IP address. But at this moment, majority of the traffic is still using the legacy way of, so I would say security, traffic volume, and also the IP address is some of the constraints that we have to consider when we deploy our HTTPS node.
I'll give you a different answer. You mentioned this thing called HTTP. What is that? I've forgotten. So, with great respect, however, no. Everything is configured for HTTPS. Everything is configured with a certificate. Everything is configured with TLS 1.3. Everything is configured with SNI. Everything is configured with the ability to do full crypto, full forward correction. I mean, all of the correct buzzwords in order to do the appropriate high level of security. All the time, every website, end of story. If a customer actually downgrades to HTTP, and I question why, then that is by their choice. And there may well be a reason for that, although I don't see it in this current day and age. So the overhead for doing an HTTPS TLS-based connection is low these days. And in the same way that I talked about earlier about deploying everything everywhere, it's the same issue. You're always deploying certificates for every single website. You're always deploying into every location, and you're always delivering wherever possible if the customer has. So we do a large amount of redirects, for example. You type HTTP, but via one of many different methods, we'll redirect to HTTPS. There is no reason. There are two statements here. There is no reason to run HTTP anymore. And if there is, please come and tell me and why, and I will gladly argue. And secondly, and I'm saying this as a content delivery network, there's no reason to run a naked website anymore. This is an old, lost idea. Put content behind some form of both content delivery, but also protection, because we sort of haven't really talked about sort of the secondary aspect of CDNs, which is doing DDoS mitigation and WAF filtering and the like. But that's sometimes a given with CDNs. So that's my response, but you sort of nodded your head in the wrong way. So
actually, I have a follow-up question. I think, from what I heard, there may be challenges in certain economies or countries that you put your cache servers, because they may have regulation that may give you like commercial risks to put your servers in their locations.
Well, maybe just quickly, maybe less controversially, but yeah, our content is 100% HTTPS. We don't serve HTTP content, so the kind of split kind of case isn't a question for us. The other thing, your second question just now is like, yes, there is economies like that, and in those cases they will not get a cache, period.
Ditto. Yeah, the same.
Yeah, that's what I want to get. Thank you.
Right, Ulrich Speidel, University of Auckland. This is a question for Matt. You were saying you had a cache node here in New Caledonia, which last time I looked at the map was actually a Pacific island, and then you later said it doesn't typically work for Pacific islands because they're too small. So obviously I understand that New Caledonia is not among the smaller Pacific islands there are. So my question to you is, where do you see in terms of the number of users on an island, so population size or type of connectivity, where the boundary is between it being worth having a cache there and it not being worth a cache there?
Yeah, I mean, to what I was saying earlier is most Pacific islands, right? We do have some. We have caches in Guam. We have caches in Fiji. We have caches here in New Caledonia. We just deployed in PNG. We have something in Timor-Leste. So we have French Polynesia as well. So there is a bunch of cases where it works, right? This is purely, as I was saying earlier, a scale thing. It's very hard to say a number of users because it very much depends on the usage pattern, right? It's essentially about the amount of traffic and the kind of amount of diversity of content people access, right? One positive aspect is about a lot of the islands is that they tend to be fairly closed communities, so there is a higher hit rate of content typically compared to like a larger country. So if I put a cache in India that has like a gig of traffic, that will have a much lower hit rate than a cache in a Pacific island that has a gig of traffic, because the community tends to be much closer. I think one of the highest hit rates I've ever seen on a small cache was the one we put into Bhutan. They seem to have a extremely closed kind of community of people all looking at the same content. But I mean, this is a case-by-case evaluation. There's no fixed user number or anything like that. But as a very rough number, typically much below a gig of traffic, a cache for us will usually not work.
Thank you.
Hi, Tashi from APNIC. I think I would like to supplement Krishna's community-based approach to caching content. Of course, we can't double our population overnight, so I guess the only way is to come together for sure. But then this also gives rise to the problem that Jethro was trying to discuss on who pays what when you actually pull content to fill your cache. So last year when we were helping IX in the Pacific, we will not name names here, something interesting happened there. There were 4 ISPs, out of which 3 had caches. Whoa, this just went down. So 3 of them had caches, but 1 did not have, but he was providing backup transit for 1 of them. So we suggested that, can you actually announce that guy's prefix to that cache? And actually he was willing to do, and they also negotiated that the transit cost can actually come down if he populates his prefix into that cache. And the traffic, IX traffic from 8 meg jumps to 400 plus. The traffic across the IX. So maybe this is something that folks in the Pacific can think of. You will end up spending more money trying to calculate who needs to pay what, right? Instead of that, maybe come together and come to an agreement like that where 3 or 4 of you come together and each one of you host a different cache from different CDN providers, and then you start populating each other's prefix to those caches, and then there is no hassle of you having to calculate who pays what, and it serves the purpose. Yes, thank you.
Sure. I think in an ideal world that's great, and there is some examples where that works, but again, we have seen plenty of examples where that might be the idea initially, and very quickly people disagree about who is benefiting more, and they'd rather suffer themselves than helping their competitor, even though everybody would win. So yeah, I'd love to see that, but in real world, I've seen plenty of examples actually in the Pacific as well, where basically people hate each other so much that rather than cooperating, they both suffer.
Hello, thank you. Hi, I am Shabnul Sami, a few weeks ex-Telecom Fiji Limited. I'm here as a returning fellow, a fellows mentor. So I'm asking this question on behalf of some of my workmates back at home country, and also in my personal interest. So what will be the impact if we limit the transit bandwidth of CDN? Like, how will it adapt to that limit? Will it try to download every new content request, or will it prioritize based on queries? Like, you know, in Pacific, we have transit issues, so we try to use that much transit for all our customers. So we always have transit bandwidth constraints. So will there be any, like, how will it adapt to that limit if you try to limit the transit bandwidth that is fed to the cache?
Yeah, so I can tell you the Akamai way of doing that. So if you have a way limit on your transit, so that's essentially mean impacting the performance of the cache field. So let's say you will be, let's say, a high so a low throughput, high latency, packet loss on the cache field bandwidth, then it's actually, if your system would detect that, then we actually basically will suspend that. But what we could do is we could work with the ISPs that you just explicitly tell us that, hey, you have a 1 gig port of cache field, but I want you to only use 500 meg, something like that. Then we can actually configure on our system to only limit the egress traffic to the end user so that the cache field traffic is limited to 500 meg. Of course, this is not an exact number because the traffic will be fluctuate during day and nighttime. But what our system could configure is basically like a soft limit instead of a hard limit on the port. Then we can adjust the egress traffic to the end user because we do have a approximate like cache ratio. Let's say, for example, we have a 1.5 cache ratio. So our system will know that for every 5 gig traffic that we send now, we need 1 gig cache field. Now you told me that you only have 500 meg cache field. Then what we do is we limit the traffic that we can send out to half of it, only sending to 2.5 gig. Then the system, then automatically, because of the egress traffic is lower, then the cache field traffic will be proportionally, usually, that will also be lower to 500 meg. So this is something that we work with the network partner. If you tell us that you have a Akamai cache node, you have a limit in the cache field, you just told us that what limit that you have, instead of our system have to detect a packet loss and then we suspend it, and the next time it's good, then we unsuspend it. Then you end up with a lot of traffic oscillation that is suddenly go up, suddenly go down, then it's actually not a very efficient in terms of cache efficiency, because the next time we bring it up again, the content may be treated as a cold content, then that means we have to fetch the content again. When we fetch the content again, then you have a limit, then it's more like a cycle that keep going up and down, and then it's actually impacting the user performance. So you basically, we just need to tell us the limit, and then we can configure on our system.
Okay.
Sure. So essentially, limit on the application is good. Limit on the port is bad. If you put a limit on the port, you'll have high packet loss, and you'll end up in CDN guys just removing the whole traffic, and it's going to use way more transit than you are trying to save by limiting on the port.
Oh, okay.
Yeah, pretty much exactly the same answer here, right? It's like if you just rate limit your cache fill, that will just break the cache, any cache, right? Okay. If you tell us this is the amount of bandwidth it can use, that can be configured and it won't use more than that. But okay, don't rate limit your transit, that will break any cache I know. Okay.
Martin, do you put any cache node inside ISP's network? And what about such situation if they try to rate limit the cache fill?
In your situation, our automatic software would just shut down the node. Because rule number one is you provide the user with a good experience. And you use this word rate limiting, and there is no sentence that includes the word rate limiting and good customer experience. So I know that that's a very sort of harsh thing to say. Yeah. And I know international transit bandwidth is both amazingly expensive and complicated to engineer, and Jonathan's talk yesterday was a perfect review of the state of the nation, which is way better than I remember that talk many years ago. But no, this is with so much live information being delivered, it's near on impossible to operate in that mode for stuff like we're doing. It just doesn't work.
So it's recommended like we should not rate limit it.
Yes.
Despite like if we try to save bandwidth, we shouldn't do it.
Yeah, Merriam-Webster, the American dictionary, puts about 500 words into the dictionary every year. This year they put TLDR in. If you don't know what TLDR is, I won't waste your time telling you. However, rate limiting is one of those things that should be removed from the dictionary and the lexicon, if possible.
Okay. Sorry, I had one more question, also on behalf of my workmates. Do CDNs have periodic updates, like a scheduled one, weekly or something? Like?
Well, again, that's what we talked about earlier, right? So the CDNs you see here are all on demand, right? So this is like if a user requests something, we will at that time pull it. So again, if you rate limit that, it will just break and your user will suffer, and we will shut down the cache. All of us.
Of course, it's far different for cases like say Netflix. I don't think we have anyone here from Netflix, but they have a model where they do the cache fill during the off-peak times at night. So that's far different, but yeah, the dynamic-based CDNs, they do it on the fly.
Yeah, I mean, this is what I was mentioning earlier. This is a completely different use case. If you have a fixed library, you can fill that off-peak whenever you feel like it. But for a real-time CDN like the folks you have here, that doesn't work, right? I can't cache fill today's popular cat video yesterday because it didn't exist yesterday.
Okay, thank you very much.
Thank you.
Okay, follow-up question. Yeah, this is Chihu from APNIC. Regarding that regulation which prevents you from putting your physical servers, can you be more explicit? What kind of regulations which will make you not install your servers in a certain country or economy?
No.
No.
But how about if the government needs you to, provide all the private certificates to them? Is it a showstopper? Or?
See the previous answer.
Okay. How about Akamai?
The only thing that I'm aware of is different in terms of regulation is China, because China always have all the websites they need a internet license, internet content license. That, but this is not. I mean, but in terms of a delivery, it's everything is the same. But just when you have to use the server inside China, then you have to conform the regulation that. Our content customer, they need to get the ICP license by themselves. And of course, you need to be, because the ICP license, you can look it up so that we can double check that the government actually have approved for this website to be launched, because the government have to scan through all this. This is because they block, like, for example, like, of course, like gambling website or some religious or website that they block, and then those come off content. But if they don't get an ICP license, then we check that and we'll not deliver that. So this is the kind of a limit that they are aware of in a national level.
Okay, thank you.
Thank you.
I have one question to CDN providers. I saw one advertisement in one of the economy saying that like we have a Google Cache, Akamai, and this much of bandwidth with this much of cost as advertisement in the economy to sell the internet from one of the ISP. So how startup ISP or the small ISP who doesn't have, the cache server can sustain on those area? Because they might not be qualified to get the cache server, but their competitor is just advertising with the, we have this cache server. Because user is, they always try to, look the features of that ISP. So what do you suggest for those small ISP and the startup ISP?
So, yeah, okay. So what I would suggest is for those startup or small ISP, because we mentioned before that scale is an issue or cache fill is an issue that we don't deploy cache server initially. But what we do is, what we suggest is you can look to connect to a IX. That makes sense, because we do connect to a lot of IX that to aggregate traffic. So if it's small ISP, if you could connect to an IX, it's actually not only for getting the CDN traffic, but you can also get peer with your other members on the IX. So it's actually benefits somehow to you. And then we could send the traffic to you through an IX, because we do a public peering policy that if you connect to an IX, then we'll definitely peer with you. And then you can get the traffic from there. Because if it's small, then it's not enough to justify cache field, but we do build cache server with a aggregated node consortium model or a IX model.
One point I want to add here is that when you say startup ISP, essentially you mean an ISP which is in the starting phase with less number of users, relatively less amount of bandwidth consumption. Of course, for those models, you have transit, and it's fine. I mean, you do not need to have caches in all possible networks in the world to start with. You can have, and I think last time when I checked, there are 60,000 ASNs in the routing table. You do not need to connect to each of them to start with as a starting point. So of course you can always start with the transit and keep an eye on your traffic profile and start offloading as you can, and that way it works.
But the competitor ISP is advertising with those words. So how that startup ISP can grow? I mean, with the customer, because. If let's say CDN providers has a commercial solution, I mean, to host cache, I mean, they can, I mean, have such a small boxes to, I mean, to start, so that they can, I mean, use that kind of thing.
I mean, this is what we talked about earlier. This is simply a technical limitation, right? If I give you a box and you have 100 megs of traffic, that box will heat the room. It will not achieve anything. This will not work. There's no such magic like, oh, you have a small box, all of a sudden that works for a smaller ISP. This is a pure technical limitation. So this is, I think Cam's answer is exactly right? Connect to an IX, potentially a consortium, but like you can't change the technical challenge there, right? Just because you'd like to have one doesn't mean it will work in your network. And that's really not something we can change. I mean, the cache efficiency only starts to scale from a certain point of traffic. And as much as I would like to change that, I can't.
We've focused a lot on bandwidth, because that's a very easy thing to see. But there's actually more variables that need to be taken into account. And if you could imagine the difference between shipping a large video file out of a content delivery network, where essentially the web browser is grabbing, if you know how video is streamed, it's essentially grabbing sort of a 2 megabyte file as an HTTPS request again and again and again in the background, and hopefully giving the end user a nice perfect streamed video that lasts for an hour and whatever. They don't see any delays or anything. Well, that's one style of content. Big files, lots of them. But it actually turns out, if you actually look at what you browse, you actually collect an enormous amount of very small files. And so bandwidth is not the only measure. You bring up a simple web page, remember that you've gone to a certificate authority to make sure that the certificate is correct, or you've grabbed the certificate, you've grabbed a fairly small or a set of CSS files, some JavaScript from here, there, wherever, because your site has got quite complicated, and then a set of resources, your logo, the images, a few other things that are there, or maybe a font file in a modern-day web page. And then finally you get down to the actual content, which may be very fleeting and just enough to tell you, hey, do you want to go here or go there? Or do you want to buy this product or that product? So radically different bandwidth model and connectivity model than somebody just streaming an hour and a half of video onto their smart TV or whatever, both of which are using content delivery networks. So bandwidth is not the only measure that you need to take into account. Large amounts of small objects collected from all over the place actually mean that sometimes you look at the importance of a CDN not by the total amount of bandwidth, but also by what its reach is. And so this complicates what we just talked about, because now you realize that in fact in every Pacific island, in the same way that every major country, they're touching our cache, end users are touching our cache for this piece of JavaScript or this certificate or for this DNS resolution, all of these small items. But bandwidth-wise, that doesn't really add up. But actually deployment, due to the mechanics of how software works and how deployment worked, is we still use this major measure of how many megabits, how many gigabits, before we can really turn around and say, yep, I need to deploy in a particular place. It's very unfortunate, actually. And we know that because one of the measures that we did was to look at how many IPs touch us over a course of a day. And it's nearly every IP. But it's for a tiny amount of bandwidth in some cases. A certificate is tiny, actually by design, but it's very important. So users, use more bandwidth.
All right, we'll
Pretty
take
much.
a question from the audience.
Yeah, hi. So my name is Pankaj Chaturvedi. I'm from Dishnet Wireless, India. I'm representing ISP Association of India here. So thanks to the CDNs, now we see hundreds of deployments across the country, wherein the Googles, Facebooks, and Akamais and various other CDNs, they have done the deployment, which has helped us in improving the quality of service to the end user. Now, I have two issues here. First question, which I would like to raise here, is that India is a regulated country. Almost on a daily basis, we get hundreds of blocking instructions from various government agencies or the courts. Now, because the ISPs have deployed the CDNs into their premises now, the question which is being asked by the law enforcement agencies is that the blocking instructions is being carried out at the gateway level, but is the blocking actually happening at the CDN level or not? Is the content still available to the end user? And because of which the smaller ISPs are facing a huge problem, wherein the government is insisting that they should remove the CDNs from their premises and it should only go to they should pick it up, the content, or get the pairing done only from the gateway providers who have the various, LEA installations done, the content management where it can be done. So I have a question that is, if we do the blocking at the gateway level, does it also mean that shortly after some time the content will be removed from the CDNs? Because this is very important for us. So then I'll come to the second question.
I want to add I want to add one point to the question since I come from India. I think a lot of confusion which happens with the regulator is not specifically about the content, but it's about blocking specific URLs in HTTPS. It's in that context. If I'm
Absolutely.
wrong, please.
Very right, rightly said.
Okay, we can start that, Matt.
I'm not the right person to ask this, quite frankly. We have established channels for law enforcement agencies that can ask that question directly.
But unfortunately, nobody is present in India who could answer that in Facebook. So what do we do? Remove Facebook?
I think we'll go with what Matt said. We'll stick with the engineering side of discussion since it's an engineering panel for now.
So secondly, again, I think I'm going to expect a similar response from all of you. In the last elections, in the in the U.S. elections, there were a lot of issues on the the content which was being generated by some other countries, other economies to influence the elections. So now soon in India we're going to have elections. So how do is there a mechanism which has been deployed by various content players wherein they have things in place to ensure it doesn't happen?
I think we do not need to take this question since, again, you are referring to an issue about content. We are talking more around caching of content and delivering on the tech part. I don't think any of us has anything to say about what we can block, what we cannot.
Anurag, I can answer that. The right place to discuss this is the Asia-Pacific Regional Internet Governance Forum. We had this in Vanuatu just a few weeks ago. There are also international internet governance forums. And in my experience, Facebook does attend the IGF and does discuss these things. So there are places to discuss these issues, not here.
Sure. The only thing I think you can take from the tech side of things is, of course, you cannot block HTTPS URLs. You can block a complete domain, which you do not want to do. And this is something probably needs to be explained to the people who are working in the regulation, the way it works and the way cryptography works. I'd now head to Krishna. Krishna, I saw in your slides you mentioned about transparent caching of content, of probably non-CDN content, because I don't think you'd be referring to content of, say, Facebook or Google, but the regular HTTP content caching. Do you think there's a future for that, considering there's more and more push for HTTPS, and you lose the ability to cache HTTPS traffic as you can do with HTTP? Plus, in my experience, the only way it has worked is around, apart from HTTP, is around torrent caching, where again the traffic is reducing. Do you see a lot of HTTP and torrent traffic in your country?
As I mentioned in the slide itself also, because the this transparent caching is going, I mean the traffic is getting down, so deploying that thing in a particular ISP is not worthy. So if we deploy in, I mean, consortium or in IX or community with the PBS system, then till then, I mean, till when, I mean, the content will be available from the transparent caching, we can use that thing. That's the concept. And second thing, definitely all the contents are moving to CDN with the HTTPS. So whoever is hosting transparent caching in the ISP, inside ISP, the cost could be higher to host those things. So better to share, I mean, with the other ISP. That's why this proposal is there. Yep.
Jethro, I have a question for you around here. Many of us are not familiar with Vanuatu. Can you share the traffic profile of users? And in traffic profile, I mean typically for end users, if we break down, say, 1 day of their usage, how much percentage do you think goes to various content players if you have done such an analysis?
Thank you. I would say large part of traffic for any ISP in Vanuatu is made up of contents that comes from the CDNs, Facebook, YouTube, and the others. And this continues to grow as more users in Vanuatu continues to depend on contents which is served by this. So, as I would say, perhaps about 60 to 80% of traffic for any provider is served by this content. So the CDNs play an important role in shaping our traffic profile.
Do you think it's the bottleneck, if let's say, if you want to offer 1 Gbps everywhere in your country, what would be the first bottleneck you hit?
I think within the urban centers that would not, perhaps that would be okay. But Vanuatu is not made up of one island only, so that is a challenge when you need to take connectivity to the other islands. And one challenge that we have at the moment is the backhaul between these islands. And that is where I think is the main bottleneck, is the backhaul between the islands. Yeah.
I think the last point I want to have to take in the discussion is, of course, we are here and we have CDNs. We must discuss IPv6. So my next question is for all three CDN players on the panel. Do you support IPv6? And how much traffic do you see percentage-wise in comparison to IPv4? And since the mic is going to Martin, if someone is living in isolation, do you know what an IPv6 is?
You know, I think I've changed my my focus over the years. Those people that knew me many, many years ago, that I spent 100% of my time focused on V6. And it's not to say I don't anymore. It's just that I'm happy with the push. I'm happy with the growth. There was a couple of graphs that got shown yesterday. Jeff Houston showed a graph of some growth and then disappearance of V6 coming out of China, which I went back and looked at, and we definitely still see that traffic there. But the reality is that we have to treat both protocols equally at the moment. One of the biggest things that I'm happy about accomplishing at CloudFlare, because it didn't exist when I joined the company. This is a negative. It existed when I joined the company, was that a user had a switch on their control panel to enable v6. By default, it was not turned on. And so a handful of years ago, we did the migration of making that switch the default of being on. And in fact, it took a lot more effort than my original sort of day 3 in the company saying, right, let's do this. So it turns out there were some issues, very subtle issues. And we went through the process of not only making everything that we did really actually work with v6, and boy, did we find some subtleties. So for example, when you're black holing a route with a /32 in v4, what's the equivalent to do in v6 on an internet exchange or to a transit provider? But I'm happy to say that a year plus, year and a half, just over more than a year and a half ago, we finally sort of made the move. We removed that v6 switch. And so the user bringing on a new zone onto our system just doesn't get to choose anymore. It is v6. It is v4. And there is no reason to choose between one and the other. And that's a good thing. Now, we still have work to do, we as an industry, to make this be absolute. But it also means that we have sort of finally got, after many, many years, to some equality point between these two protocols. Going forward, and if I look at sort of the ultimate sort of v6 rah-rah moment, will be that when we do CDNs that are embedded with inside, let's say, mobile networks, LTE networks, or even 5G networks, where we can actually really control everything from the DNS query through the data path, through the IP routing, that at that point we can force everything into a v6 only mode. And that's predominantly just to make things cleaner going forward and making sure that that end user, again, the talk yesterday about what was going on with Jio in India, and T-Mobile in the US, where you're seeing default of XLAT 464 deployments. That actually makes the v4 path from a mobile device inefficient compared to v6. The natural path off of that mobile device is v6. And therefore, you want to make sure that for that particular device, that you forcefully, as the content delivery network, move to v6. So that's sort of the new focus on v6, and much more interesting than, if I may say, than 5-10 years ago of going, please, just do v6.
Martin, it's with most of ISPs, often meet, I always tell them, put more v6. You'll move a lot of traffic because of the content towards the content player on v6 and remove the CGNAT bottlenecks. So in typical eyeball ISP experience, it's anywhere from 50 to 80% of traffic moves over to v6 if it's deployed for everyone. How is the experience for CDNs? How much traffic percentage-wise you see on v4 versus v6? Can you share?
Yeah, I did a blog on this about a year and a bit ago, but I should update the numbers, but the number spread is pretty similar. So when you look at an ISP that's got a fairly good v6 deployment all the way to the end user, and you've got fairly modern devices being used by that end user, then it's not hard to, in fact, see for a specific AS, 50% of your traffic coming in over v6. You can see this because of happy eyeballs. You can see this because, as I said, modern devices, so you aren't dealing with somebody with a legacy Wi-Fi router at home that actually just is v4 only. So that thing has finally died. More
likely the power supply has died, and that they've got a nice modern Wi-Fi gateway from their provider. So we actually see this, and we see it all over the place. So we saw a very large amount of mobile users in Taiwan jump up in V6 usage maybe 5-6 months ago. This is a good thing. We've seen the same in many countries around the world. And in some cases with managed CPE on a broadband level, we see these jumps where, for example, although it's old news now, AT&T sort of enables 5 million households for V6 within a handful of months. And the traffic truly does follow that. It is not 100%, absolutely not 100%, but it is getting there and is high enough, with one exception. Dear networks in the audience, please remember to do your routing configuration the same for V4 and V6. This is one thing that we are seeing, is we're seeing a big delay in the quality of V6 routing purely because people haven't thought about it, haven't finished thinking about it. If you have V6 enabled, turn up V6 at your internet exchange. Think about your internal routing, turn up all your transits with V6. Finish the job.
I'm going to interrupt you at this point since we are running out of time. So just one last question. Matt, can you share same question for you, V4 versus V6 traffic percentage?
Yeah, so like on global numbers, it's about 20% on V6 right now. In individual networks, that can be in the high 90s. I mean, again, mobile players, Geo was mentioned as an example, several US mobile players, also some broadband players like Sky in the UK, again, managed CPE, they're almost entirely V6, right? And that shows on a country level. Like if you look at India, India is about 50% V6, and that's primarily because of Geo. But yeah, as a global number, about 20%.
Okay, thank you. So since we have already run out of time, I would like to finish this session. We thank our panel members for their time. Thank you.
Thank you.